Okay, listen here, all of you. So today we are going to do the experiment for the load characteristics of DC compound generator. It may operate two different mode, differential as well as cumulative mode. So this was the actual circuit diagram. You see here, one DC shunt motor is mechanically coupled with the DC is compound motor, compound generator. So we are the generator, in the sense we need to give the mechanical input. So for the mechanical input in here, for the experiment purpose, we can't take it directly. So here we are connected the mechanical coupling. For the mechanical load purpose, we are connected the DC shunt motor. Here the DC shunt motor is mechanically coupled with the compound generator. So we need to analyze the load characteristics of the DC generator. So here the three DC shunt motor we are used. So we all know that was the DC shunt motor. It's made for DC supply. This is the DC supply. This is the circuit breaker and the 3-point starter. Okay, through this we can start the DC shunt motor initially. Then you can fix the rated speed. You can start now. You can start it now. Yeah, you can on it through the 3-point starter. Yeah. Yeah, now the machine is getting started. You see, initially this is the field rheostat of the DC shunt motor. It should be the minimum position. This was the input. This is the output. So this is the minimum position. Now you can measure the speed. So the speed is not rated speed because we are connected the rheostat. So the speed was below 1500 RPM. So we need to increase the field rheostat. Yeah, gradually, and now you can measure the speed. Now you can measure the speed. It may the 1500 RPM. It may come. Yeah, likewise you can adjust the rheostat and fix the 1500 RPM. Now I adjust the field rheostat. So it may come for 1500 RPM. You can check it. Once the rated speed is fixed, how much it's came? Okay. Yeah, now we are fixing the rated speed of the DC shunt motor. So the same speed generator also rotating. So this is the field excitation for the DC compound generator, right? So you can increase the field excitation, and parallelly, once if you are increasing, then only it is getting started for the generation. It is the DC compound generator. So you need to close the single pole switch initially. After closing this, the supply generated supply it may shown in the voltmeter, right? So that is the field excitation. Similarly, you need to give. So while you can increase the field excitation of the DC compound generator. You see that is the field current. That is the field current. You see here the field current is getting increased. Similarly, the voltage also getting generated while you are applying the field excitation, right? Increase it. You see parallelly the voltage is getting increased. Both you can see the field current and the generated output voltage, right? So the rated voltage, you vary up to the rated voltage. The rated voltage is how much? 230. Increase it. You can see it now. Now it is 230. So it's enough. So the generator now it is ready for load. So you can close the switch. So you are connected here electrical load. So you see here the various load. The generated rated current how much? 10 ampere. So up to the 10 ampere you can apply the load. So initially you can on the main, and you can apply one by one up to 10 ampere. This is the 10 ampere, 2 ampere. Then this is 1 ampere, 2 ampere, 0.5, 0.5. Likewise you can apply the load 0.5, 0.5, 1 ampere load. Now it is 2 ampere load. Entirely you can note down all the reading. See now it is 4 ampere load is applied. 2 ampere load is applied. You see here the load current is getting increased, then voltage is getting down, and field current also getting down. Okay, there is now it is connected in the differential mode. So again you can, now it is how much? 2 ampere again. If you want you can apply the load. So now it is 4 ampere. Parallelly the load is getting, the load current is increased. Similarly the generated voltage is getting down, and the ammeter reading also, that is the field current, field excitation also getting down. So likewise up to 10 ampere you can increase the load and you can note all the reading. Okay, you can plot the curve, that plotted curve for the load characteristics curve. That is, we can analyze for the loading efficiency of the generator. It may useful for the testing of the machines. Okay. So now you can remove the load one by one. Off it. Remove the load one by one, and you can switch off the mains and remove the DPS switches. So now it is load is getting removed. Then similarly here you need to remove the field excitation of the generator. Okay, you reduce it. Yeah, now you are reducing the field excitation, so the generation also getting down. You see the voltmeter is getting down because you are removing the field excitation supply, right? So you can open it, so it is reached 0, so the generation it is not reached to the voltmeter, right? So now again you bring the rheostat, the motor rheostat also the minimum position, you bring it minimum position. Yeah, the minimum position, bring it. You bring it minimum position, and also speed is getting down, and you can remove the input supply. No. As input supply, the 3-pan starter, it is automatically getting down because of presence of no volt release coil that you may study in the theoretically in the DC machines or different starting methods of DC machines. Okay, it's have three different starter you may already theoretically studied. So that is the 3-pan starter. While you are using the load test in the DC series motor, there you are using the 2-pan starter, and the common motor while you are conducting the load test, the 4-pan starter you may use. So that all you may theoretically studied. This is actual 3-pan starter. Okay, you no need to while you are shutdowning the machine. That means while you are removing all the load, while you are trying to off the machine, you will remove only the circuit breaker. Okay, you no need to touch the handle of 3-pan starter while you are stopping the machine. Okay. Okay, thank you.